Hi, I'm Sai, and this is a video for pattern recognition course final project. And this is my project. My project is a comparative analysis of classification techniques for cancer prediction. So let's start with classification techniques. So classification techniques are basically computer programs that take in data and infer new results and observations based on the given data. So classification techniques, they usually depend on features of the data, and based on the features we can use various classification techniques which will fit our criteria. uh, Classification techniques these can be broadly classified as two parts: eager learners and lazy learners. Eager learners take in the training data, they build their models, and after building the model, whenever there's a test data or queries that they need to run, they run the query on the already built model to give out outputs. Whereas lazy learners, they just store in the training data, and whenever the test data arrives, they start computing it then. Because of this property, they are called lazy learners. We are going to study 5 classification algorithms through this project, and we are going to use them on cancer data sets to find which classification algorithm works best for cancer prediction. K nearest neighbor is one of the easiest algorithms to learn. It's a lazy learning technique. What it does is it just stores the data point in an n-dimensional grid, and whenever a test data appears, it just takes in the k nearest neighbors of the data point, and we get the mean out of those data, and the mean is thrown out as our prediction. um, because this is so because this is not a very good way to do it, and the k value might very vary. It might be very small or very large. uh, we use weighted KNN mostly because and weighted KNN, what it does is all the nearest neighbors get a higher weight, and neighbors far away get a lower weight, because and hence the nearer neighbors contribute highly towards my final result when compared to farther neighbors. We can look at an example here. Here this point is we need to classify it as blue or green, and the k value is 3. So we take in 3.3 nearest points, which is this and this, and we get the we take the average, which obviously will lean towards blue, and hence we use this, and we hence classify this thing as blue. This point is blue. Logistic regression is also another technique. What it does is it calculates probability of an event belonging to a certain class based on a logic function. So we just throw in a sigmoid function, and we calculate the probability, which will give a probability between 0 and 1, and based on that value we classify data. Naive Bayes is also another classifier. Naive Bayes assumes that all the events are independent. So uh, what it does is it basically just applies Bayes theorem to that. This should technically not work, because most real world data is not independent, and there are a lot of dependencies, but somehow this seems to work, and it seems to be giving good very good outputs. So uh, this is also being widely considered as one of the good classification techniques, and because there isn't a lot to do, this is very easy to implement, and also very easy to it's not costly at all. Decision tree is an eager learning approach. What we do is we take the training data and build a decision tree from the training data, and uh, once we build that tree, and whenever test data arrives, we traverse the tree from top down based on the decisions, by test data, and which whenever it reaches the leaf, that is our final output, or the label that we throw out. For example, this is a decision tree, and as we can see, at each level we need to go we need to take a decision, whether true or false. We fall down to a next level, where we need to take a decision, and finally we are classified A, B, C, D, or some other classification based on all our decisions. So this is how a decision tree works. So because we are uh, it is very easy to overfit decision trees. we can get all records into certain leaves and work work them out like that. So that's why uh, there are techniques called pre-pruning and post-pruning. What pre-pruning does is it it stops the building of trees whenever it reaches a certain height, so that there are no additional leaf nodes which may in future lead to overfitting. What post pruning does is it takes the whole tree, it prunes away all the leftover leaves, and from that we get another and from it and that is the tree that we are left with. Random forest is basically collection of decision trees. We take a bunch of decision trees and we and basically all decision trees give out an output. We take the most popular output and we send it out as our output. Uh, because these trees have very little correlation between them and they are pretty much very different, we an error that might occur in one tree will be covered by other tree, and this will serve as a great advantage. This is an extremely efficient algorithm which, because we are using a lot of trees, and it also requires a lot of processing processing power because, well, we are using a lot of trees. So this is my problem statement. So uh, my my project is basically cancer prediction. I take in cancer data and predict if it's malign or benign. So I'm using various classification techniques to do that. um, and all the classification technique that we discussed above, and we are trying to understand which classification techniques works best for cancer prediction. There has been a lot of research going on for cancer prediction, and hope this best project that I'm doing will help someone who is trying to choose a good classification algorithm. So for doing this, I'm using two data sets: cervical cancer data set and breast cancer data set. The cervical cancer data set contains 36 attributes like smoke, if the person smokes or not, age, number of pregnancies, etc. And it is taken from 858 women. Because of privacy concerns, most of the there are a lot of null values in it, so we had to do some imputations. Let's just look into the project. So this is the project. Here, as we see, this is our data set which has age, sexual partners, smokes, number of years they smoked, IUD, STDs, and all such, all these columns. And this biopsy is the target that we are trying to reach. One represents that the person has had cervical cancer, and zero says that the person does not have cervical cancer. So yeah, that's why we do some computations in the class. These we are trying to find the data type of the uh, column here, and then we are trying to replace all the unknowns with nans. And now what we do is we do imputation. What imputation does is there are some values which are 100%. That is, we have all the columns, all the columns of all the records are filled for those values. We use those values to and run a machine learning algorithm from with those values to estimate uh, the values that should be here, because these are medical data. Mean and median won't do a great job. That's why imputation is done. And for this imputation, we are using a decision tree classifier a lot. And yeah, from this, where we by doing this imputation, we will remove all the null values from the project, and we'll have a very good database to work on. So these are all the imputations that we are doing on each class. This is for genital herpes, and these are for Muslim contagion, and this is how we do for all the columns. I mean, there are 32 columns and there are like 15 columns which have null values, so we do those for these 15 columns. And then now we check of how many null values do we have here. And as we can see, because of these imputations, there are no null values right now. So let's now just jump into our actual code, and these are the base models. These are this model is logistic regression, as we can see here, which we take from scikit-keras. This is a decision tree classifier we take from scikit-keras and stuff like that. and we have run it. I've run it just now, and we got these from the training scores, and these are the test scores. uh, we can so yeah, this is pretty much how cervical cancer prediction works. Similarly, I also worked with, um, as we can see here, logistic regression and random forests have given out the best output as expected, because well, they are good classifiers. So next is breast cancer data. This I've taken this data from UCI, Kaggle, and UCI and Kaggle. So basically, Kaggle takes it from UCI's. So yeah, this is a very clean data set. It does not have any null value, so I did not have to work a lot on the data set. And it has like 11 parameters like radius, perimeter, etc. So, and for each parameter, for radius, for example, for radius, we add the radius mean and radius standard error, and make it, and that gives us 20 more attributes. So 10 plus 20, we have 30 columns, and that's our data. So let me just go through the project. So this is a project. I'm just, let's say, run out. So we import the libraries, we check the dimensions, we have 32 attributes, and the final thing is diagnosis. This diagnosis is the target, which tells us if our project is running or not. Sorry, if this tells us if the patient has cancer or not. So yeah, we are splitting our data into train and test, and each time I'm getting, so basically for each classifier I'm checking the training accuracy and the test accuracy. This is done using confusion confusion matrix. Basically, these are predictions that I did from split, and we just check these predictions. We get a 2 by 2 matrix, and from this 2 by 2 matrix I do this calculation to give out my accuracy, and I print out the accuracy. This is the accuracy for logistic regression training data set, and this is for the test data set. So as we can see, we did for random forest, we did for decision trees, we did for Gaussian naive Bayes, and we did for k nearest neighbors and stuff like that. So yeah, these are the outputs that we got, and I've tabulated the outputs here. And as we can see, random forest and naive Bayes and random forest, logistic regression, and decision tree have done extremely well here. So I just did a comparison for classifiers for training accuracy and test accuracy for breast cancer and cervical cancer, and I also did some graphs. So we can see here for test accuracy, both cervical and breast cancer, um, random forest and logistic regressions have done really well, and decision tree comes a distant second. And even here, random forest and logistic regression and decision trees have worked really well. So yeah, these are my conclusions. So taking from the above data, what we can say is random forest and the logistic regressions are the best way to go for cancer data. Random forest works the best, but if we don't have the processing power, logistic regression or decision tree would work as fine. We saw that naive Bayes here for our cervical data did not do really well. So I don't recommend naive Bayes for cancer data, and yeah, random forest and logistic regressions should work great. So yeah, these were the conclusions that I made from the project, and this was my complete project. Thanks a lot. It's been great. Thank you.